Write the reaction
of
mechanism for
alkanol
the
synthesis.
acid-catalyzed hydration of ethene to yield ethanol as shown below, where ethene gas reacts with water in the presence of acid to form ethanol. First of all, we are going to show how water interacts with the proton from acid, because this is an acid-catalyzed reaction. So water reacts with the proton to establish a dative bond to form hydroxonium ion. Now, in the first step, the hydroxonium ion is going to attack the ethene. The hydroxonium ion is going to protonate the ethene, as shown. So one of the protons in hydroxonium ion is going to leave its bond pair electron with oxygen, which has a positive charge. And when that is done, the hydrogen becomes positive. Now, being positive makes it an electrophile. That is, it is hungry of electrons. And ethene is electron rich. One of the bond pairs, the pair of electron in the double bond, will now be donated to this proton. And we have this. So here, the proton has successfully entered to create a new bond with the ethene. This particular species has a carbocation. So it is called carbocation intermediate, where the carbon is positive here. And the hydroxonium ion will now become water. And this is the water. Now, in step 2, this water being a nucleophile, that is, it has electron pairs to donate, it will now attack the carbocation intermediate by donating the lone pair and establishing a new bond, thus. So here is what happens. One of the lone pairs go in here, and a new bond will be established. So here is a new species that is formed. Water has finally integrated itself into the carbocation intermediate. But when you look at this, you will see that there is a hydronium ion here. The oxygen is positive. Therefore, this molecule is still susceptible to further reaction with water, being rich in electron. So what happens is that hydrogen, any of these two hydrogen atoms, will leave its bonded pair and become detached from this molecule, and it is called deprotonation. And for that to be possible, water must be available to receive this in order to re-establish the hydroxonium ion. So step 3 is called deprotonation, and look at what happens. This bond pair will be left with oxygen, and hydrogen becomes plus. And because of that, another water molecule will come out, which is electron rich. Then it will donate its electron to the proton, and there will be deprotonation to re-establish hydroxonium ion, thus. And here is the ethanol, because once this particular species is deprotonated, we now have OH ending here, which defines this particular molecule as the ethanol. And this is the target compound. And at the end, our hydroxonium ion will be reproduced